Welcome to Chapter 1 of the 46RE series transmissions. This chapter is a brief introduction of this unit, including vehicle applications, identification, and basic function. My name is Keith Clark, and I'll be your host for this course. It's a great day to fix transmissions, so let's get started. The 46RE series transmission is a fully automatic, 4-speed, rear-wheel drive, electronic control unit. 4 forward and 1 reverse gears are produced using 3 planetary gear sets, 2 bands, 4 multi-clutch packs, and 2 roller-type one-way clutches. The PCM commands a governor solenoid that provides signal oil relative to road speed, much like a centrifugal governor. This oil produces first through third gears. Once third gear is achieved, governor pressure is commanded high. On-off solenoids control the 3/4 shift and TCC apply. Fourth gear and TCC apply occur when adequate road speed and torque demand allow. A conventional throttle valve is used for pressure modification relative to the throttle opening. A throttle cable connects the throttle valve through levers to the throttle body. On late model 48RE applications, the throttle lever is replaced by a throttle actuator motor. The 46RE series transmissions are updated versions of the A518 and A618 units, also referred to as the 46RH, 47RH transmissions. As mentioned previously, a centrifugal governor is no longer used on the RE units. The 46RE was designed to mount behind gas V8 engines, while the 47RE is found behind V10 and diesel applications. The 48RE is an updated version of the 47RE, which incorporates upgraded electronics, higher torque capacity, and upgraded hydraulics. These units can easily be converted between 2-wheel drive and 4-wheel drive versions by simply changing the extension housing assembly. Note that there are several variants of the main case as well as extension housings. These differences are make, model, and year dependent. We will discuss these variations in later chapters. Shown here is a breakdown of the internal components of the transmission. The front case portion of this unit is the equivalent of an old TorqueFlite A727 3-speed transmission. A compound Simpson planetary gear set produces first through third gears. The overdrive section has a simple planetary gear set that receives input from the front unit through the intermediate shaft. The overdrive section operates in direct 1-to-1 mode in all ranges until fourth gear is selected by the powertrain control module. Dodge uses these units in their truck and van applications. Note, the input torque capacity increases relative to the second digit listed in the transmission identifier, where the 46RE is the lightest duty and the 47 and 48 applications are considered heavy duty. On the driver's side of the transmission, you will find identification numbers stamped in the case just above the pan rail. On later model applications, a label can be found affixed to the case above the transmission solenoid connector. The information on the label is the same that is stamped on the case. The unit part number, build date, and serial number are provided. The production location and date codes are also included. The vehicle identification number can always be used to match the vehicle application with the unit part number that was originally installed in the vehicle. You would need to access the sales code information through YTech or local Mopar dealership service department. This is the clutch apply chart for this unit. The overdrive section remains in direct drive mode until fourth gear is selected. Note that when the vehicle is in reverse, the overdrive direct is the only clutch pack that's active in the overdrive section. This is a spring-applied hydraulic release clutch. If there happens to be slippage in the reverse gear under load, it could be an issue with the clamping force applied by this spring. The overdrive and TCC solenoids are a simple, normally open, on-off type solenoid. The computer commands them based on engine load, vehicle speed, and other parameters. The 48RE is capable of lockup, apply in all ranges. However, first gear lockup command has not been observed on any of the OEM calibration levels. The gear ratios are the same for all models, even the 48RE with the steel planetary carriers. The 46RE series transmission has two external sensors, a neutral safety switch and an output speed sensor. The early designs use a screw-in type neutral safety switch as shown here. This requires a special Teflon coated washer to seal the sensor to the transmission case. Always be careful installing this. Use a touch of assembly lube to secure the washer to the switch while installing it. Otherwise, the washer may not seat correctly and get damaged. Use hand tools only. Also, use hand tools when installing the output shaft speed sensor. The housing is plastic. Do not over torque. The 48RE replaced the screw-in neutral safety switch with a push-in manual lever position sensor. It is a neutral safety switch combined with a range signal. Inside is a resistor network that converts the movement of the manual lever to an electronic signal that is sent to the dash. There is a cam attached to the manual linkage inside the transmission attached to the valve body. This cam is unique to the 48RE application. The plunger follows the ramp of the cam. Based on the manual lever position, the plunger will be compressed a specific distance that will produce a unique voltage for each range. That voltage is converted to the range displayed on the dash. The case has a screw-in adapter plate that provides a base for securing the range sensor to the transmission. A special spanner socket is required to remove and install this. Another item that you'll see on 2005 and later 48RE applications is a transmission throttle valve actuator. This item replaced the throttle cable. It uses a motor to control the throttle valve movement. The motor attaches to the transmission case and engages directly onto the throttle actuator lever on the valve body. Note that the case design changed. Bosses were added to allow the motor to be secured to the case. Cooler send and return ports are indicated here. Shown here is the standard OEM cooler configuration. On most models, there's a check valve in the return line, cooler line near the radiator. It is recommended to remove this due to high rate of failure, especially after a catastrophic transmission failure. Contamination causes this check ball and spring assembly to stick and restrict cooler flowing. Restricted cooler flow leads to overheating and poor torque converter clutch control and or gear train failure. There are several cooler line configurations that use auxiliary coolers. Locations can vary based on year, make, and model. Auxiliary cooler replacement is necessary if the transmission produced excessive debris and contamination. Shown here is the early 5.9 liter diesel application. Note that the one-way check valve is located on the auxiliary cooler as indicated. Shown here is the later model diesel application. This design was carried over into the 68 RFE application as well. There are other variations that use an additional air-to-oil cooler in front of the radiator. Some models will have a special design send line with a rubber hose section built into it, as indicated in the picture. This is in place to act as a shock absorber for hydraulic pulses that occur from the pump when the vehicle is under heavy load. If this line needs to be replaced, always use an OEM or equivalent design. Failure to do so can cause auxiliary cooler failure, cracks, or leaks. Shown here is the later model application that incorporates the air conditioner condenser with the transmission oil cooler. The air conditioning system would need to be evacuated in order to replace the cooler on this type of system. This further emphasizes the need to positively identify which system you're working with. Failure to do so could prove costly. There are several opportunities for pressure testing these units. It is recommended to use two gauges to compare pressure differences. Note that there is no dedicated line pressure tap. Accumulator pressure can be used for all forward ranges. Use reverse servo tap for reverse pressures. It is recommended to always use a scanner and pressure gauges to diagnose problems quickly and accurately. Since governor pressure is electronically controlled, anything from commands to mechanical, hydraulic performance, and feedback can be the root cause for problems. Use this chart along with scan data to help you. The 46RE series transmissions have a common shift gate. Note, all applications will have a button to disable overdrive or fourth gear. This is electronically controlled. Shown here is the operation of the transmission in each range indicated. Note that manual second gear range gives you a first gear start. Once in second gear, you will have engine braking available. The 46RE series transmissions all use a cable and linkage setup to control the manual transmission range selection. The early dash indicator is a mechanical assembly that is replaceable and adjustable. The model year 2003 introduced an electronic dash display. This change goes along with the range sensor update that was mentioned earlier. If the electronic display fails, the instrument cluster needs to be repaired or replaced. Of course, you must assess the range sensor, manual linkage components, and related circuits before determining a cluster is faulty. Vehicles using the 46RE series transmission will also have an overdrive cancel switch located either on the dash or on the end of the gear shifter. The switch is designed to limit upshifts to third gear or command a 4-3 downshift depending on driving conditions when depressed. An indicator in or near the switch will illuminate when this function is active. This will conclude our chapter on unit introduction of the 46RE series transmission. We want to thank you for participating in our virtual training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.